Alright, so this is section 3.5 where we are going to be talking about transformations of functions. Now, before we get going, you need to know that this is a rather large section and there is a lot of information that goes into it. So do not feel bad if you feel like you need to pause, stop, replay this lecture multiple times in order to comprehend the content. Okay? Now, also, if you remember from the last lecture that we did, I had made mention of the fact that these notes were going to be slightly different than the ones that had been uploaded to Blackboard previously. So this is one of those examples of where things are slightly different. Here, we're going to start out with the concept of increasing, decreasing, and constant functions. Okay? Now, in order to do increase, decrease, or constant, you need to focus on the domain. So we've already done an extensive discussion about your domain. So for you to recall, remember that your domain is the x values, or taking a walk along the x-axis. Okay? Now, we have three definitions that we have to follow. Your first one is this one here. It's for increasing. Increasing says for all a and b in the interval over ab, we have that if a is less than b, well, that implies that the function at a will also be less than the function at b. So essentially what that means is we are implying that wherever you started, when you draw along that graph, you're going to draw in that upward increasing motion, i.e. away from your body. Decreasing is the exact same definition. However, it implies that your function at A has to be greater than your function at B. So this means that wherever we're starting your graph, when you first start drawing it, decreasing would imply that you are drawing down towards you or pulling your pen towards your body. Okay? The last one is constant. So constant essentially means that there is no change. So no matter what your x values are, your y value stays exactly the same. There's no change. So we have that if your a is less than b, then your function of a will equal your function at b. Okay? So one possible example that you may see is something like this, where you are given this graph here and you are asked to state your intervals of increasing, decreasing, and constant. So first and foremost, we have increasing, and so we have to look at where in our graph are we actually increasing in our values. Okay? So first and foremost, we need to look at all places where we would pull our pen away from us. You're going to start over on the left-hand side. Okay, so we're going to start looking here. And we are going to look at the graphs as individual pieces. So if we put our pen over here at the start, we've got this straight line that goes to a certain place and then stops. And then if you notice, we look a little different. So our next starts up here at this place, and we are going to travel down, but then we change directions. So in changing directions, we now switch, and notice my pen is going to come up in a different direction. So in this case, I am pushing or pulling away from my body. And then the last thing that we have is now we're going to start, and again, we're pulling in a downward direction. Okay? So those are the three things that are happening in my graph. So first and foremost, let's look at it. I want to know where I'm increasing. Increasing says I have to be traveling in this direction. Well, the only place I'm doing that is over this interval here, so my pink line. And we're using just the x values. So you see that this is going to start right here when x is 1. So here we're at x equals 1. And we are going to travel all the way through until this point here, which you can see is going to be this value at x equals 4. And so my interval of increase-decrease is going from 1 to 4. So hence, this is my interval right here that I'm using. And so this is my increasing piece. Okay. Now, when I want to look at decreasing values, okay, I'm looking at where am I going down towards myself. So I'm looking at going in this direction. Okay, so I've got 2 of them that are traveling in that direction. So I need to look at the intervals that that's happening. So this one here is starting here at x equals -2. And on the other side, we're starting at x equals 4. Now this is going to travel, of course, down to that change of direction point, which is at 1. So my first point of decreasing is going to be here at -2, 1. And then my second one is going to start here at x equals 4, and the arrow down here tells us that we are looking at x being positive infinity. So that makes this my second decreasing function. And since we have to write these as interval notation, we do just that. Now we have to look at the last piece. And notice this last piece is a horizontal line. So notice my arrow right here is telling me that I'm starting at x equaling -infinity. And I'm going to travel along my x-axis till I get here at -2. Thus making the interval from -infinity to -2 my constant interval. Okay, so you are going to have to be required of knowing how to label your functions or label your graphs and identify where your intervals are increasing, decreasing, or constant. Now, another thing that we have to look at is called relative maximum and minimum values. Okay, so again, when we're talking about relative max and min, we're talking about your peaks or your values. Okay, so here we're talking about a relative maximum, and my relative maximum is going to occur at this specific spot right there. Okay, we're talking about that value. Now, since I only have the one peak, it means I only have the one relative maximum. However, when talking about my relative minimums, okay, which would be these over here, we have 2 of them because notice we have 2 valleys. So we're looking at this point here and we're looking at this point down here. So those would be our relative minimums. Okay. Now, the biggest thing that you have to keep in mind is that your value is the minimum or maximum specifically at the y coordinate. Okay. So, in other words, we would be talking about that value where we have, say, k equals. Okay.